In this video, we are going to work this problem. It says the position function f of t of an object projected vertically upward is given below, where t is greater than or equal to 0. What is the maximum height the object reaches? Okay, so this is the position function. And basically what's going on is that, just draw a little picture here. Something is shot like vertically straight up in the air. So it's going to go straight up like this, and then it's going to reach its peak, right, and then come back down and fall back down like that. So it's shot exactly straight up into the air, right? And this function is the position function, so this will give us the height of the object at any time t, okay? So what we need to do is to figure out where the highest point is. All right, and the key to doing that is to realize is when the object is at its highest point, its velocity will be 0. Okay, and just think about it, right? The object is going up, right? So it has positive velocity, right? And then up at the very top, when it's at its very peak, it stops for just a fraction of a second, and then it starts going back down again. So that's what we're going to do to figure out the time at which this thing is at the object is at its peak. We're going to take the derivative, right? Because the derivative of the position function is the velocity, right? So the derivative is going to be minus 4t plus 24. Okay? When you take the derivative of that. All right? And so then we want to know at what time is the velocity going to be equal to 0. So we are going to solve v of t equals 0 to figure that out. Okay? So when we do that, for us, v of t is minus 4t plus 24. So we set that equal to 0 and solve that out. So we get minus 4t equals minus 24, so t equals 6. Okay, so this is a time value. The units weren't given up here, but let's just say it was in seconds. So this tells us 6 seconds, right, after this object was fired up in the air, it is at its peak. Okay, and had they asked us, hey, how long does it take for the object to reach its maximum height, we would have said 6 seconds, right? But that's not what they want. They want the actual maximum height. All right, and so we know, right, what the position is or the height is at any time t. All right, that's given by the position function. So what we're going to do is to take this time value that we got from setting the velocity function, the derivative equal to 0, and plug that back in, and that will tell us how high the object is at 6 seconds. So let me erase that. Oops. All right, so to finish this problem off, we are going to do f of 6. So we're going to take 6, right, and plug it in for t, right, into the velocity function. So we get minus 2 times 6 squared plus 24 times 6 plus 90. Okay, and working that out, 6 squared is 36. 36 times negative 2 is negative 72. And 24 times 6, that's going to be 120 plus 24, so that's 144, I believe. Plus 90. All right, so working that down, it's just easier for me to combine these two. So that will give me negative 72 plus 90 will give me positive 18. So that's going to be 144 plus 18. And so that's going to give me 162. Looks like 162. All right, and then whatever units were given to you. In my problem, I didn't give any units just because it's just easier for me to do that than how the problems are set up this semester. So, but if you're not in my class watching this video, make sure that your teacher's probably going to want you to put the answers on there. So whatever the height, the feet or meters, right? That's make sure you include that on your answer if your teacher wants you to do that. Okay. All right, that's it on this video.